Inscribed angle theorem cases. Case 1. The center of the circle is in the interior of angle ABC. This proof was outlined previously. Case 2. The center is on a side of angle ABC. A two-column proof was just presented. Case 3. The center is in the exterior of angle ABC. The proof is left for a homework exercise. Here's a cool little animation showing the measure of an inscribed angle is equal to half the measure of its intercepted arc. Here's an example. Find the measure of angle T. Alright, so that's this angle here. We see that this arc is 48 degrees, so this angle is going to be half of that, making this 24 degrees. Find the measure of arc TQ. So TQ is this arc here. We see that the angle is 50 degrees, making this twice as much at 100 degrees. And finally, the measure of arc QR. So here, well, what we can use to our advantage is the fact that this is a semicircle. From here, over this way, and this way, this is going to be 180 degrees. So if this is 100, that makes this portion 80 degrees. Two inscribed angle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. By the transitive property of equality, if two inscribed angles intercept the same arc, they are congruent. In this case, the measure of angle ADB equals the measure of angle ACB, since both intercept arc AB. In this example, the measure of angle DAC here equals the measure of angle DBC here, since they both intercept arc DC. Alright, when we put both of those examples together, we see that these two angles are congruent and these two angles are congruent. Parallel chords theorem. In a circle, parallel chords intercept congruent arcs. Given circle O and parallel chords AB and CD, prove that arc AC is congruent to arc BD. We begin with our given information, then we're going to draw CB, a line that connects those 2 points. Because alternate interior angles are congruent, we know that this angle is congruent to this angle, which means the measure of those angles are equal, because that's the definition of congruent angles. And because an inscribed angle is half the measure of its intercepted arc, we know that this angle here, the measure of it, equals 0.5 the measure of this arc, and the measurement of this angle is 0.5 times the measurement of this arc. So, due to substitution, we know 0.5 the measure of this arc, BD, equals 0.5 the measure of this arc, AC, and then we can divide both sides by 0.5, and we see, because of the definition of congruent arcs, that the arcs are congruent.